This is Juno 8 and it's question 4a. Here's the question again. State the essential conditions for the formation of stationary waves. So those are, again, you have to have two waves travelling in opposite directions. And then they have to meet and interfere with each other. And they must have a constant phase difference or the same frequency. Or the same frequency. A tight string of length 0.6 meters is clamped at one end and attached to a vibrator at the other end. The vibrator is connected to a signal generator. The frequency of the signal generator is gradually increased from 0. At a frequency of 122 Hz, the appearance of the string is as shown. And you should recognise that as a fundamental frequency or the first mode of vibration. Calculate the speed of the progressive waves which give rise to this mode of vibration. Now the first thing you have to calculate is the wavelength, and that's only half a wavelength. So lambda over 2 is 0.6 meters, so lambda must be 1.2 meters. And therefore you can just use V equals lambda F, and that's 1.2 multiplied by frequency is 122 Hz, and that gives you 146.4 meters seconds to the minus 1. The frequency is gradually increased and the next two modes of vibration are located. On figure 4.2 and figure 4.3 sketch these two modes. Mark on these figures the frequencies at which these modes occur. So you know that the next one has got two complete loops, and that's one complete wavelength. So you know that lambda is equal to 0.6 meters was the length of it, or the distance between them. And therefore frequency we have to work out, they're going to be travelling at the same speed, and therefore F is equal to V over lambda, and that's 146.4 divided by, first of all, 0.6 meters, and therefore that frequency comes out as 244 Hz. And then the second one, which is the next mode of vibration, you have three complete loops, say about there. And therefore lambda, you've got 1.5 lambda, so 3 lambda over 2 is 0.6 meters, and therefore lambda is equal to 0.6 by 2, which is 1.2 over 3, gives you 0.4 meters. And therefore F is equal to V over lambda, and V again is at 146.4 divided by 0.4, and that comes out as 366 Hz is your answer.